We want to find the term containing x to the 9 in the expansion of this. So if we think about our formula, the problem is we don't know which term it is. We don't know if it's term 5. We don't know if it's term 7. So we don't know the value of k. We know that there's some term that is going to have an x to the 9. If we put in everything that we do know, we know that n is 9 because that's our exponent. So it'll be 9 choose k because we don't know what k is. We know that our first term is 3x squared, and it will be to the power 9 minus k. And our second term is negative 2 over x, and it would be to the power of k. Now, we do know that whatever term it is that we find, so this tk plus 1 on the left, is going to be something x to the 9. That's what we want to find. And so I'm just going to rewrite what's on the right. It'd still be 9 choose k, 3x squared to the 9 minus k. Now what we're going to do next is we are going to temporarily ignore the coefficients. So I'm going to ignore that because I don't even know what number that is. I'm going to ignore the 9 choose k because that's going to be a number that when you multiply it all together in the end, that's going to be a number in front. I can ignore this 3. And I'm also going to ignore this negative 2, but maybe I'll ignore it next step. What I want to do is I want to use only my powers, my base of x and my exponents, to figure out what k is. So on the left-hand side, if I ignore the coefficient, I would just have an x to the 9. On the right-hand side, if I would use my exponent laws, I have x squared to the power of 9 minus k. Can you see that that would be 8x to the 18 minus 2k? If I applied my exponent law? And if I applied my exponent law over here, I'm still going to keep that negative 2 for a second. But I'm going to ignore that as well. And I'm just going to look at my powers. On the right-hand side, if you have a power like this x to the 18 minus 2k, can you see that that's in your numerator? I'm going to ignore this too. Oops. Can you see that this would be in a numerator? And I have an x to the k in a denominator. Can you, this power is in my numerator. This power is in my denominator. What exponent law can you do then? You can subtract. So I'm going to do that, and I would have x to the 18 minus 2k, and I'd have to subtract k. So you see that red negative 2 to the k that I circled? I'm ignoring it now, because all that would do would affect a number in front. And I just want to look at my power with the base of x. Now in our exponents unit, what did you do if you could get both sides to the same base? Does that not mean that this has to equal this? So then 9 has to equal 18 minus 3k. 3k is equal to 9. And k is equal to 3. So we just figured out that the only way that you could have an x to the 9 is if it was term number 4. Because if k is 3, then you need to find term number 4. So now, if we look back at the question, it didn't say find which term. The question said find the term containing x to the 9. So now, part 2 of this question, we have to find term 4. Term 4 will be 9, choose k is 3. Our first term in this expansion was 3x squared to the 9 minus 3. And our second term was negative 2 over x to the 3. So this is the same as the questions are from before. You simplify each of those separately. Go to your calculator. 9, choose 3, that's 84. 3 to the power 6. $729. X squared to the 6 will be x to the 12. And negative 2 cubed will be negative 8. And x cubed at the bottom. So once you've simplified each one shortly, I'll get your question in a second. Once you've simplified each one separately, now you can multiply your numbers together. So 784 times 729 times a negative 8. Negative 489,888. And what's going to happen with an x to the 12 on top and an x cubed on the bottom? Going to be x to the power of 9. And now we've found the complete term that has an x to the 9. Okay, questions?
Before we go any further, can you go back to step 1 where you took out every number we've ever understood?
Where you ignored all the numbers that you understand? So
What did you do in the second, third, fourth step?
I wanted to solve for k. So in step 2 is just writing out the formula with what we know. And the one thing we didn't know was k, because we didn't know which term contained the x to the 9. Whatever term it has, it's going to be some number x to the 9, because that's what the question's asking. Okay? So there's a term containing an x to the 9. So it's going to be, we found out that this circle right here was negative 489,888. That was that number that's there. But we don't know that yet. But we know that it has an x to the 9. So the other information that we're given from our formula says, well, it's going to be 9 choose, and I don't know what k is. It's going to be 3x squared to the 9 minus k. Again, I don't know what k is. And I'm going to have my second term to the power of k. The only things that are going to help me solve this are our powers. Because only thing I have as information is it has an x to the 9. I don't know the number in front. So anything that's going to affect the number in front is not going to help me solve it. So I just ignore that. So I've circled 9 choose k. If k is a number, this is a number. 3 to some power is going to give us a number. And negative 2 to some power is going to give us a number. And all of those later on, right? Those were these numbers here, here, and here. And they made this number in front. But the only information that helps me figure out what k is are the powers. And I have a power here, x squared to the 9 minus k, which becomes x to the 18 minus 2k, using your exponent law. I have a power here. It's going to be x to the k on the bottom. I just used it. I could have put a 1 there, but I need to have something on the top of my fraction to make sure you realize that that x is in a denominator. Because if I'm ignoring it, it's like having a 1 there. I just left it there one more step, and then I ignored it. Okay? So if your exam requires, and some exams have had this where they've required an algebraic solution to this, this is what you're going to need to do. If you're not required to have an algebraic solution to this, what you're going to do is at this step, right here, after you've set it up, you're going to say, use an educated guess, and I hope, like, we know that k is supposed to be 3. We've already figured that out. So let's say you guess something wrong. You're saying, I want to find a k value that simplifies to give me an x to the 9. So I'm going to pick a random k value other than 3. Pick a number. 7. So if you chose 7, what would that mean here? This will be 9 minus 7. How many x's would I have in my denominator? X to the 4. Can you see that? If k is 7, you'd have x to the 4 in the and how many, in my numerator. And how many x's would I have in my denominator? I would have 7. That simplifies to x to the minus 3, which is not x to the 9. So obviously k equals 7 is wrong. Should k be bigger or should k be smaller? K should be smaller. So then you would say, well, try another value of k. Let's not guess right away yet. You want k smaller? 2. So if you had chosen 2, this will be 7. How many x's would I have in my numerator? 14. How many x's would I have in my denominator? 2. That makes x to the 12. It's not equal to x to the 9. Now do I need a k value bigger or smaller? Bigger. And it won't take you very long with mental math, a little bit of mental math, to figure out that k needs to be 3. And if k is 3, how many x's would I have on the top? X to the 12. How many x's would I have on the bottom? X to the 3. What does that simplify? X to the 9. So you know that it has to be term 4.
So could we just guess and check on
You can, unless the question says you need an algebraic solution. Okay? And yeah. Then you could just say which term it is. Well, I would probably explain it more than just guess and check, because I considered only the powers, and then I tried a number and noticed it was too big. It's kind of like guess and check, but it's more educated than that. Yes?
Just to make sure, like for everyone's benefit, this is never going to be a multiple.
This is not a multiple choice. This is long answers. Okay? So these are the questions that say find a term containing something, containing an x to the 9. And our last example, there we go. Find the constant term in the expansion of. So we have to go back to some of our grade 9 definitions. What is a constant? What's that? Doesn't change, but when you're talking about a constant term, what is a constant term? Okay, on your quiz tomorrow, some of you are going to ask this question. When I put find the constant term, you're going to say, what's a constant term? And I'm going to say, well, I'm telling you right now that some of you are going to forget. So this is what I'm going to tell you on your quiz tomorrow, is if you forget, find all 13, because there's 13 terms in this expansion, and maybe one will jump out at you. But that's the long way to do it. Now, a constant term in math, if I gave you x squared plus 5x plus 7, what's the constant term? The 7. How do you know it's the constant term? It's just the number. It has no x's. So in this case, having no x's is the same as asking the question from before, saying find the term that has x to the 0. So on this one, if I put my formula in, tk plus 1, n is 12, choose k, I don't know what it is, 5x cubed to the 12 minus k, and negative 2 over x to the k. What we want is we want all of our x's to cancel out. So let's use the guess and check method. Tell me a value of k you'd like to try. 5. if you plug in 5, can you see in your numerator you would have x to the 21. In your denominator you would have x to the 5, leaving you with x to the 16. Do we need a bigger or smaller value of k? Bigger, because you want to have more of them on the bottom, right? And less of them on the top. So tell me another value. K equals 7. Can you see, I'll slide this up just a little bit. On the top you would have x to the 15, on the bottom x to the 7. Giving you x to the 8. Did they all cancel out? No. So we need a bigger value of k. 9. So if we plug in 9, this will be x to the 9 on top, x to the 9 on bottom. That simplifies. So now all you would have to do, you know k is 10. I mean k is 9, find term 10, and you'd find the constant term. And I'll leave that for you, unless you want me to do it right now. Yeah? So if you want to see it, now you find term 10. It's going to be 12. Choose 9. Term 1 is 5x cubed to the 12 minus 9. Term 2 is negative 2 over x to the 9. Again, calculate each of these separately. Go to your calculator. It's possible. 220. 5 to the power 3 is 125, x to the 9. 2 to the power 9, negative 512 over x to the 9. Multiply your numbers together.
I'll leave you for a second. I'll just get my jacket. And a present. How are you?
Negative 14 million is the constant term.
Mr. JR, you staying here for a little bit?
Yeah, I'm around, yeah.
Because I just